to my YouTube channel. Now in this video, I'm going to show you on Physics Form 4 Chapter 3, Force and Pressure. Just like with my many others video, Maths, Physics, all my videos are not intended to replace your textbook, neither to replace your reference. You still need to read on your reference and texts. My video is meant to help you to summarize what you need to know, so that you will pay attention while you are reading your text, so you have some idea what is important, what is things that you need to know, and your reference text is there for you to understand what's happening. Okay, to start with from Physics Chapter 3, Pressure and Force. So first of all, you need to define the meaning of pressure. What does it mean by pressure? Okay, pressure in physics it means it's a perpendicular force. P equals to pressure equals to perpendicular force per unit area. Okay, this is equation. But put into word, pressure is actually a perpendicular, meaning 90-degree perpendicular. Perpendicular force acting on 1 unit per area, right? 1 unit area of surface. So there's some keyword here would be perpendicular force, 1 unit surface area. Okay, perpendicular force. So graphically, put in a graphic, it means if you have this, okay, a floor or a surface, and then the famous one would be if you have a cylinder, okay, the mass of the cylinder m, so gravity going downwards, so the amount of force, gravitational force pull equals to mg, right? F equals to mg, okay, going downwards. If it were to be placed onto the surface, so this is the surface, right? And this is my area, A pi r squared. So the force is going downwards and it will impact on this area. So the pressure feel by this area will be F divided by the area, and be sure in the unit of SI unit. And the unit for pressure is a derived unit, and unit for pressure therefore would be force is Newton per meter squared, or special unit is called Pascal. Just like force, you have Newton. PA, Pascal. Therefore, 1 PA, 1 Pascal is basically equivalent to 1 Newton per meter squared. Alright, that's our unit. So, let's come back to this diagram. Pressure equals to force per area for mathematically. Now, if you look at this equation, what happens is you have tried to imagine, some high hills, some big hills, okay, towards the hill, a big one with a sharp one. Okay, the difference would be the pressure exerted for this one here as compared to the tiny one. The area would be different, right? Basically, this is, if I want to label this A1, this is A2. Obviously, A2 is less than, or A1 is more than A2. So for the same mass of people, so the same persons, the mass is constant for the same person. If these ladies, you want to compare the pressure exert on the floor, the left side and the left and right pair, what happen? The pressure 1 will be therefore less than pressure 2 on the floor. So because why? According to the equation over the left hand side, now if pressure equals to force per area, therefore that will be mg. This is the mass of the human, mg. So what happened when my area increase is what happened? Therefore my pressure reduces. Okay, because area is inverse proportional to area. Okay, you compare the value of 1 over 2 with 1 over 20. So obviously 1 over 2 is more than 1 over 20. Right? So if the base value increases, the overall value will reduce. Okay, it's always the cross-sectional area. Okay, that's going to count. This is the cross-sectional area. This is the cross-sectional area, or perpendicular. I mean the force perpendicular to the area. This is the cross-sectional area. Okay, so this is basically all about this chapter. Yeah, it's not short. Yeah? You need to read on to your reference text. And this is the introduction, basically. Next thing would be pressure. Not only exert. You will not only see pressure at your shoe. You will see it in liquid as well. Yeah, not only on object but also liquid. Where will it be? Fluid or liquid. Okay, put it on the next page. We have pressure in liquid. Okay, and pressure in liquid. Earlier on, we have pressure equals to force per unit area. This is general equation. It will be the same equation, just that you need some modification over the force. Okay, previously if it's human, then it's mg. But what happened? We have liquid. Now, I will give you a scenario. Let's say for a divers. Okay, a divers. All right, maybe. Okay, divers with oxygen tank, of course. Okay, divers. Okay, all right, divers under the sea or under the sea, and good enough. You have a sea floor. Okay, this is cross-sectional view. Then we have always water above it. Okay. Now what happened? Well, of course, underneath. Okay, but what's underneath it is not important. What's important is always the force, the mass above it that pressing onto it. If you are now the divers, you will feel that you have this volume of water above you that's pressing onto you. Okay, this amount of mass. Okay, I'll square it out. So this is the amount of water pressing against you, against the divers. Okay, you feel pressure by this liquid caused by this amount of water, because again pressure is always the amount of mass pressing on this area. So this is the area, this is the cross-sectional area. It's supposed to be the cross-sectional area of the human, but I'll make it simplify. I'll put a cuboid instead. So what happened? Now your task is need to find out what is this force. Okay. First of all, you know force is equal to mg. Always the case is mg. G is the gravity. Now is you need to find out what's the mass. What is the mass of water? I mean, you don't expect yourself to go scoop up this amount of water and then you measure the mass. You can't do it. So mathematically, good news is you get to learn here. New thing, not new, you have heard of it, I'm sure. You have density of water. You will know it, right? Density, symbol rho, pronounced as RHO, rho, Greek words, equals to mass per unit volume. It's a scalar because it's all about numbers and numbers. It's a scalar quantity. So here is where you will get your mass of water, provided you know its volume. So what happened? Therefore, my mass is equals to rho V. Is this volume? Then, what is volume? I mean, how you could measure its volume, right? Then, here it comes in another parameters. No, here the surface area. This is the surface area A, and this is where the height or the depth where the divers dive. How deep or how much water above these divers, right? Or how deep, right? What's the depth of it? So if you know this parameter, therefore your equation you simplify as rho, volume is area times height, right? So if you have this parameter, then you are quite fit to go. What happened? Therefore, your equation P of water, pressure caused by this water, will therefore be, again it's the same for A, just that now your P water, W subscript, equals to mg. mg over area, and m is rho A H, where I get it from the previous equation. Here, transfer it there, okay, to here, okay, and G remain as gravity over A remain as it is. Yes, you may cancel off the area, and therefore the equation simplify. Pressure caused by liquid or water would therefore be rho H G. Now, this is one thing that you need to look at or consider, which is in this equation for pressure caused by liquid, the area is not important, but the height is important. H is important. The area, the surface area for liquid, is not so important. Okay, so this is the next thing you should consider, because now they'll give you, in some past year question, they give you different shapes and size, okay, at different height, and they'll find out which one has the highest pressure. Okay, say for example, you have a big pyramid, okay, compared to a small base. Okay, good thing is they have the same height of water. Okay, this is H, and this is also H. The same on the surface. Then they ask, which has the highest pressure? Okay, so the answer to this, they are of the same because the height is the same. So P1 is equals to P2 because the height is the same. Okay, no need to memorize it because based on this equation, rho hg, the height, pressure caused by any liquid is determined by the amount of height, okay, from the surface. If you want to explain it by using this equation, F over A, they will say, why is that so? You have higher, the area is smaller, then isn't it that the pressure is higher? No, you do not consider that because what happened for this constant instant, yes, the equation is always the same. The area reduced, but at the same time, the mass is the same, right? No, it's not, right? Over here, this is for, you can't use this equation. You need to use a derived equation to determine, to find out the pressure caused by liquid. As long as it's a liquid, then yeah, this is how you do it. Now likewise, if you put it sand, for example, then you need to find out if the amount of sand, they are the same. If the amount of sand is the same, the force is the same, then therefore they should behave the same. The pressure should be the same. Here, regardless of whether H, no, in this case, since the H is the same, therefore the pressure would be the same. Alright, so I don't want to spend more time on it. You may read through it, go through this equation, and it wouldn't be so hard to really understand what's happening. Okay, so for pressure caused by liquid is rho hg, rho is density, h is the height of water, g is the gravity, which is 10 meter per second for Form 5 only. If you are not in Form 5, then maybe you need to use 9.81. So you doesn't need to care about 9.81 at the moment. You are in Form 5, you are in Form 4, you're in SPM, as long as sitting SPM. Gravity is 10 meter per second. Okay? Forget about 9.81. Doesn't need to go into that. Just stick with gravity is 10 meter per second if you are sitting for SPM. Alright. So next instance I want to share with you would be a scenario. You need this to help you think or better understand what's happening. Well, you have Genting Highland or in the high hills. Not high hill, I mean in a higher altitude. You know? Yeah, also in this chapter you get to learn a new word called altitude. Altitude is a measurement of how high or how far away from the sea level. Okay, altitude. So if you have a house built near here, I mean uphill, of course there are maybe road around it, okay, to go in there, okay. Doesn't really need to matter how it goes up, but our concern now is the physics science behind it. If you are here and it's compared to if you are here, okay, which condition or which point would you going to experience the most pressure? Okay, where will you experience the most pressure? Okay, again, this is not liquid, but this is air. What happened here is the amount of air, the particle here as compared to here, the amount, this is the amount of mass of air pressing onto you, I mean 3D, is more, isn't it? Pressing onto you. As compared to here, it's less. I mean, the height, right? H1, this is H2. What happened above the cloud would be outer space, there's no air. So the amount of mass above high hill is less than downhill. So what happened? Pressure equals to rho Hg for liquid, or for fluid. Fluid is any particle that take the place of, will fill the place of the fill the volume. Those are liquid. I mean those are called fluid, right? So here H1 is greater than H2, therefore P1 would be greater than P2. That is the reason to why you will face greater pressure downhill, and you go uphill, then you have less pressure. And if you want to plot a graph, there's also a graph to recognize. Okay. Altitude versus pressure. This is where 0. Now if we plot a graph, higher altitude meaning this higher, I mean above the sea level. Here is above sea level, greater value. Lower level, what happened? You will see the graph would be inverse proportional. Okay, meaning at higher altitude the pressure is lower. Higher altitude, lower pressure. Alright. And something that I need to stress here would be pressure in liquid or fluid, air for this instance, is actually free from the effect of surface area. Okay, this is the equation that tells that is only the height. P is direct proportional to the height. Okay, the height above it. P is direct proportional to H doesn't mean that you have a linear graph. No, it's not the case. It's that when the height increases, or the depth increases, you don't say height, you're giving it, a wrong perception. Maybe it's the depth. When the depth increases, therefore the pressure increases. So in this case, amount of matters, amount of air, the mass above it increases, over this volume increases, therefore the pressure is higher. That's where you get this equation. Alright? You need to read on to your textbook reference on the characteristic of pressure in liquid. Okay? You need to consider is always the depth. Okay? The great amount of mass above it, then press on it, therefore the pressure is higher. One example experiment that you might have seen. You have to perform it. Perhaps you have Eureka. I think this is called Eureka cup. Okay, you have water. You fill with water. Maybe slightly water. Raise it up. Okay, then of course you need to have a basin to catch the water. Otherwise, the surface would be. What happened is that the over this content, we will find that the water over the lowest, because there are lots of water down here. This is the height, the depth, right? H1. This is where H2. And this is where your H3. So H3 will be the highest pressure, therefore you expect this to be the furthest, followed by the one here, closer, and this one would be less, right? Okay, so this is what you will normally see. Okay, for now in SPM, this is the diagram of you should know, and many more others, because it's always the case, the height is important. Okay, in your reference there is an experiment to prove that, I want you to read on it. Also the application of pressure in liquid. Okay, how do you apply it? Okay, you should read on yourself the application of pressure. How do you apply pressure? Construction of dam, things like that. And then some others theory. Atmospheric pressure, that's what I've shown you here. Maybe you want to find out about atmospheric pressure. Let me shed some light. I'll explain over to you what is atmospheric pressure. Is what I've shown you here. This is where the atmospheric pressure comes. Okay. Now, you may notice what happened. Water boiling. Okay. Water boils at high. Here boils at relatively lower temperature as compared to downhill. Because what happened, if you have this water, you try to boil it, you put fire onto it, try to boil it. What happened is water, you define boiling point. Boiling point is a pressure when the vapor pressure same as the environmental pressure, right? So that's the boiling point. So here, if you are now here downhill, if you're boiling, in order for water to boil, what happens? You have lots of pressure pressing against it. So in order for this water to be released, to be vaporized, released, then you need higher energy. So therefore, T is higher, temperature is higher as compared to uphill, here. If you want to boil water here, then the temperature here lower and you get boiling. Why is that so? Maybe here is 98 or 97 degrees, water start to boil. Whereas downhill here, maybe you need to have 100 degrees C. Here maybe you need about 97, high hill, 97 degree, then water start to boil. Why is that so? Because at downhill, in order for water to boil, to get out from the surface, you need to provide more energy so that you overcome the atmospheric pressure that's pressing against it, preventing water from leaving. Okay, so this is the one of the effect. Atmospheric pressure is always the case. The weight of the thick layer. Okay, here this is thick layer, isn't it? Thick layer of air. That thick layer of air, you have lots of, caused by the weight of a thick layer. Weight, okay. Weight. The weight of thick layer of air. That's going to cause this atmospheric pressure to be higher and downhill. And many others application, you need to really look into it. Okay, so just before that, I'm going to give you an example. I'm going to show you what does it mean, how to calculate that. Okay, let's go back to our previous example, a divers. If you have learned atmospheric pressure, you have learned the pressure in liquid. What happened? Initial example, divers. Okay, I mean you have this human, right? I mean divers, oxygen tank. Okay, divers is always about always the depth, right? The amount of depth, amount of water above it, the mass or the weight of water. Now you do not forget there are air here too, right? There are air and also there are water. So the this air is caused by the atmospheric pressure, ATM, atmospheric pressure. This is caused by water. So therefore, if you want to find out the total pressure on this divers, P total, be sure you sum the pressure caused by this atmospheric pressure is quite constant, okay, plus your rho Hg, depends on how deep it dive. Standard condition, the atmospheric pressure will be in the range of 10 power 5 Pascal or Newton per meter square. If the height, now you are told if height is 450 meter, you dive so deep, okay, and you're given the density of the water is 1200,002 kg meter squared cube. Then height is 450 standard unit times 10 Newton per meter Pascal. So you need to sum them, therefore you get what? 550 kilopascal. Okay. What I will show here is not about the calculation. I'm sure you know how to do calculation, right? It's just that the atmospheric pressure is this much. It's around that 1.1 times 10 power 5 or 1.0 times 10 power 5, depends on the question. Normally, the question would state what's the atmospheric pressure, but be sure you sum them. And you need to read onto the question. Would the question ask you for the total pressure, or the question asks you for the pressure caused by this liquid? Right? It's very tricky. You never know what you ask, but read on the question carefully. But for P total, be sure to include atmospheric pressure. It's amount of mass above you. Okay. Then after you know all the calculation, read through the calculation, then do also make a summary of the apparatus, atmospheric pressure, measurement of air pressure, instrument. Okay, I'll call it instrument. In SPM, instrument for the measuring of maybe liquid pressure or atmospheric pressure. Okay, read on it. How does it work? Especially for maybe I'll give an example, give some guide. You have what? Mercury. Mercury barometer. BERO, barometer. First one. Then second one will be manometer. You see manometer quite a lot in objective question. And then Borden gauge. And then the last one, I think you might want to look at aneroid, ROID, aneroid barometer. In some reference textbook, they don't have one of it, or maybe you have one of, or maybe you left one of it. So what you do, you may Google for this, or Wikipedia. How does it look like? What is it? Okay. Mercury barometer. I mean, you read through the concept. It's always you have mercury. You have a long tube. And also some question they ask you, why can't they use water but they always use mercury? Okay, the height is always 76 centimeter mercury, or 760 mm, depends on the unit you want to use. Why they cannot use water but they use mercury? Look for the answer from your text. Okay, in mercury barometer, why mercury? Okay, answer this question. I think it helps you to better understand it. But be sure you know how does a barometer look like. This is how. Whereas for manometer, manometer is a U curve, normally used to measure the pressure of the gas. Okay, you may use liquid here. Okay, then of course here this side they feed through some gas, and then it will be neutral by the atmospheric pressure. Okay, so the total height, okay, this height and this height, this is caused by, this is the pressure of the liquid plus the ATM. Then you will know what's the pressure of this gas. Okay, then Gordon gauge is an advantage because it doesn't use liquid. It's just like a meter gauge. You have a gauge, okay, goes around it, left, right, swing around. I mean, you of course you need to fit through some holes, you know, then you will be able to find out what's the pressure. The unit is always in Newton, but not always, but most of the time is in Pascal. So this is very useful. This is the only gauge that is going to show you Newton meter squared. Otherwise, others require you to do some calculation, right? Likewise, the aneroid barometer. For aneroid barometer, is a very good one because it's measure the altitude as well as with pressure. That's the advantage. Okay, normally it comes up in objective question. You need to read on it. You can't just rely on this. Read on it, find out how does it work. Okay, and those are the characteristics I've summarized with you. You need to read on to your text, yeah, even if I've summarized with you. And also, kinetic theory gas, you need to read. Okay. In this page, not only these two, the third one would be kinetic. This is an important theory, not theory, theory of gas. Okay, gases. Okay. They talk about 207.3 at 207.3 degree Kelvin. All the gas are freely moved. Okay, one experiment is from the Brownian motion. Okay. Okay. And then talk about they do not collide. I mean, we say collide, and they do not lose energy, as we've learned in chapter 2, and also collision of the molecules are elastic collision, okay, with the wall or with each other, and they do not attract to each other. Okay, so this is an important theory that you should know it. Be sure you read it. Give yourself a week time. Okay, use 1 week of a time. Read through your text. Then only you go through my next video. At the same time, you try on at least I think 15 to 20 questions. Okay. With that, I'll see you again. Or with that, stay tuned to my next video. Thank you.